Okay, in this lesson, we're going to look at how to write an equation or inequality from a word problem. And so I've given you 4 really important steps to kind of help think through as we look at these word problems, because we know that word problems can be pretty miserable. So the first thing I want us to do is we're going to identify important words and numbers. You're used to doing that. I want us to then determine what we are comparing, and we're going to write this down so that we know exactly what we're comparing. We're going to identify our constants, and we're going to identify our coefficients or rates, because this is really important. So the first thing I want to talk about is what are some examples of constants that you might see in a problem. And so the important thing, we know a constant is just a number. It's something, but in this instance with words, it's something that happens one time. So an example would be if you are shipping a package, a lot of times you have to pay a shipping fee, a one-time shipping fee. Or if you join a gym, sometimes you have to pay a membership fee just to join, like a one-time fee. It can also be a flat fee, or it could be a starting amount. Maybe we're talking about our bank account. It could be how much we start with in our bank account. Those are all examples of what a constant might be in a word problem, something that happens one time. We only pay or count one time. And so then we know coefficients. Remember, a coefficient is the number part of a variable term. So the 3 is the coefficient right here. And a lot of times coefficients are given to us as rates. And so there's lots of different ways we could see it, lots of different words. One way you might be able to identify a coefficient is it might say each time, because that's going to indicate multiplying. It might say every time. That would be another indicator of a coefficient. It might be a rate like dollars per month, or it could be miles per hour, something like that. Or it might be like dollars per pound. Those are all examples, and basically it's anything that's going to indicate multiplication. Okay, so I want you to pause the video for a second, and I want you to read the first word problem to yourself, and then start the video back up. And so what we need to pay attention to here is, first of all, we're talking about Jerry and Victoria. And some important things to notice would be to know that Jerry earns a salary of $45,000. Victoria earns a salary of $54,000. Jerry's is going to increase $2,500 per year. And Victoria is going to increase $1,500 per year. That's kind of the important information here. And then the question, what we need to pay attention to, is that we're looking for when Jerry and Victoria are the same. So that's step 1. Step 2, we want to determine what we're comparing. Well, we're trying to see when is Jerry the same, which means equal to Victoria. So that's what I mean by determine what you're comparing and write it, because that's going to be really helpful. And so now what we need to figure out is what are our constants and what are our coefficients. So remember, a constant is a beginning amount, a one-time fee. So this $45,000 for Jerry, that is his constant. And this $54,000, that is Victoria's constant, because that's what they are starting with. It's a one-time amount. Where it says increase of $2,500 per year, that's going to indicate multiplication. That's a rate. So that's going to be our coefficient for Jerry. And then for Victoria, it says $1,500 per year. And so that's going to be Victoria's coefficient. So now to write the equation. Jerry started with $45,000 and he's increasing, so increasing would mean adding $2,500 per year, and it already told us that X is the number of years. So what I would do is I would do 2,500 times X, because every year, X years, Jerry earns $2,500. So that's Jerry, and we want to put him equal to Victoria. So Victoria started with 54,000 and is increasing, so we're going to add. If it said decreasing, we would subtract. And she's increasing by $1,500 per year. And so that's what our equation would look like. We don't have to solve them. That's it. That's all we want to do. I do want to point out that we could turn the equation around and switch our terms. And so this would be the same exact thing. We could also flip-flop our equal sign, like we could take our things and flip them, right? And so then that would still be the same thing. But on the left, we've got Jerry. On the right, we've got Victoria. And every single time, we're going to be looking for these constants and looking for these coefficients. So let's look at the next one. Read it to yourself, please, and then restart the video. Important for us to notice, we are talking about company P, which charges $350 for each trophy. And what do you think that is? $350 for each trophy. Hopefully you're noticing this word each. That's going to be a coefficient. Okay. And then it says company P charges a one-time fee of $25. So something that happens one time. Remember, that's a constant. So that would be the constant for company P. Then we've got company R, which charges $750 for each trophy. So that again is our coefficient. And a one-time fee of $17. And so that would be our constant. No, our constant. Okay, so now it says which inequality, so that's a clue right there that we need to use an inequality symbol, can be used to find X, the number of trophies, that can be ordered so that the total charge of company P is less than the total charge of company R. So that's really important right there, because that's going to help us write our statement. That company P, we want to know when it is less than company R. Okay, so that's what we're comparing. That's our equality statement. So let's look at company P. Charges $350 for each trophy. Remember, our trophies are represented by X. So $350 for each, $350 times X. And a one-time engraving fee of $25. Well, if they're charging us, we're going to have to add that on. So plus 25. Remember, we could have subtracting. Okay, is less than, and then company R charges $750 for each trophy. So $750 times X. And a one-time fee of 17. So plus 17. One thing I want to point out about this inequality is what if we switched it around? We could have company R over here and company P on the right. And so if we did that, our symbol would look a little bit different because we still have to say that company P is smaller. And so it's always a possibility that they could have a different option. And so we have to be flexible and we have to be able to recognize when it's the same thing. So there would be another version. It still means the same exact thing.